everyone. Welcome to this month's Dev Talk webinar. My name is Dan Qualiana, work at Zebra Technologies with our ISV Partner Program and helping with some of our developer outreach. Today's session is going to be talking about how we can connect a Raspberry Pi board to Zatar. And we have Tom Berarducci, one of the product managers of Zatar, to go through that. But before we dove in, I wanted to just remind everyone that if you're looking for more information on Zebra's technology and developer tools, you can go to developer.zebra.com. If you like these webinar series, you can see the URL on the screen there. We have all the information about them there, as well as recordings from previous sessions. We also have those posted on YouTube. And one of the new things that we've done with those, we've now added closed captioning and translations for Spanish and Chinese to about half of them. So if that's something that kind of fits your language needs better, we're hoping that that can help you out. So again, developer.zebra.com. And I guess one other thing, we actually have a lot of exciting new updates in the developer tool area. And so we are going to be doing a few more coming up than what we've normally been doing. Normally we've been doing once a month, but now we have, over the next 2 months, we're going to be going about every other week. So starting September 7th, we'll be having a Dev Talk focused in on a new tool that we're releasing on the printer side to help people who are creating web-based apps connect to their printers. And then on 2 weeks after that, September 21st, we'll be reviewing the updates on the latest EMDK as well as the LinkOS, a multi-platform SDK. And then after that, diving into some other web technology with Cordova, how to work with Zebra devices and Cordova. So we'll be posting those invitations and registrations soon, and we look forward to talking to all of you at those sessions as well. But right now we're here to learn more about Zatar. So Tom, thank you very much for joining us, and you want to get started now.
Hi, thanks Dan. Hi everybody, I'm Tom Berarducci, Director of Platform Product Management for Zatar. I've been at Zebra about 5 years, pretty much since the beginning of the Zatar IoT activity. And today we're going to talk about oops, here we go. Yes, hopefully you can see my screen. Dan, let me know if something doesn't come across right. Today we're going to talk about connecting a Raspberry Pi to the Zatar IoT cloud service. So yeah, when I started about 5 years ago, IoT was not well known, but since then it has become pretty much a phenomenon, with these projections, these crazy projections that most of Internet of Things, 50, 25, 70, 75 billion devices connected to the internet, all making our lives better and optimizing our business processes. Right now, as of right now, I think the hype has far exceeded the promise, if you will. But why is that? It's mainly because it's actually really very difficult to do what the IoT is promising. Apple has a lot of devices out there, and they've connected them up to the internet. They've done a really great job. But to be fair, Apple is dealing with exactly one device type, their own device that they build. And the IoT, the concept of the IoT is talking with, all different types of device types, thousands maybe of different device types with, different performance requirements and functions and use cases and different security needs, and whether it's consumer or whether it's enterprise, what have you. So it's actually a much, much harder problem. And unlike typical cloud services, an IoT cloud service not only connects to other cloud services and applications and things like that, but it also connects to the edge, right? It connects to the physical world. And the physical world is messy. It's got a lot of details and a lot of variability, and especially when you start talking about any type of device in the world, it becomes difficult. And legacy devices are a lot harder because they didn't anticipate the IoT when they were designed. So that's why I think things are maybe not as fast, taking off as fast as people had thought. I do believe we'll get there, but I think there's a lot of road between here and there. So what we've done at Zebra's Zatar system is we've tried to make it easy to hook things up. What I'm going to show you today is we wanted to come up with something which was, okay, more generic, right? So we picked, okay, a box running Linux, and what's the cheapest, most ubiquitous thing out there we could think of with a Raspberry Pi, pretty obvious. And so how do we hook this thing up to the internet? And we're using Zatar, but we're also using some licensed components from ARM that hope to make it easier. So that's what I'm going to talk about today. So I'm going to provide an overview of Zatar very quickly. I got a lot to cover. It's probably going to take 40, 45 minutes. And I'm going to do very high-level stuff very quickly. And I'm going to try to dive down into the details. I'm going to try to touch on everything you need to know to actually replicate this yourselves using what we've provided. And hopefully by the end of the talk, you'll kind of understand the lay of the land, how things are hooked up to Zatar, how devices in general need to be hooked up to the internet, what are the considerations, and a little bit about ARM's component we're using and some of the standards we're using, and get resources to go investigate that further. But you should be able to, by the end of this, go replicate this yourselves, which I think is the main goal. All right. So who's this for? This presentation is for devs, primarily those that want to know about Zatar and connecting things to Zatar's IoT cloud service, but also if you want to know a little bit about ARM mBed and what it does and what it provides, because there's only a few major companies out there that are helping with this connectivity issue, and ARM is one of them. All right, so what's Zatar? Like I've said before, it's an IoT cloud service, and there's a lot of them out there. There's probably bazillions of them. And the idea is to be able to connect devices, heterogeneous devices, up to the internet and abstract their details and their properties and methods into something more homogeneous that a developer can use in their own applications, either the devices themselves, remotely access them, or device data, the data the device provides. That's the idea. And what we've done at Zatar is try to do that in a way which provides enterprise-grade connectivity, but also does it in a way which is standards-based. And I want to talk about that for just a second. So here's your obligatory architecture diagram for Zatar. And the basic message here is, allows you to connect your devices to the platform and then provide that capability through a REST API to applications. And the main message in this slide is, if you can see my mouse, I don't know if you can see it or not, but over on the left-hand side where your device is, you know about your device, and you know about the code on your device because the idea is that you've written it, right? And you have the domain knowledge about how that device works and what properties and methods you want to expose up to the cloud. And so you have to write the code such that it talks to whatever cloud service you want to connect to, but you also have to describe those capabilities somehow to the cloud service so that the cloud service understands how to talk to the device. And we're not quite to the point yet in the world where devices self-describe in a software and hardware agnostic fashion, and everything's wonderful. So we're not quite there yet. I believe that's where we'll end up going, but that's not where we are. And so we've developed this avatar concept with Zatar, which is basically a digital representation, a virtual representation of a physical thing. It's essentially just a data structure, big JSON data structure that describes your device, and it's dynamic and interactive, so through our REST API. But the question is, how do you populate that data structure? How do you get the right information in and out of it so that the guy on the right-hand side, programmed to the REST API, doesn't have to know all the details? And we do that through what we call an avatar definition. So the definition is the thing that describes to the Zatar the details of your device, the avatar definition. So you need to connect, and right now we're using what we call cloud-optimized protocols. But you also have to describe that capability into a way that the cloud can understand it, and that's what we use the avatar definition for. Once you've done that, the cool thing about Zatar is the fact that all the domain knowledge that required to understand the device remains on the left-hand side. And on the right-hand side, It's a simple REST API that any application developer who understands that can write to. And once you've written to the API to talk to one device, it's pretty simple to go and write to talk to another device. You don't really need to learn something new. So the key thing we tried to do with Zatar is to utilize technologies and standards which are relatively open, relatively ubiquitous, or will be, and things that, you have to learn stuff when you program to a new platform. Every developer does, and they're always thinking like, oh my God, I have to learn this. Is this going to be useful in the future? What if I have to change from one platform to another? Can I leverage the information? We've tried to pick technologies that we think will transcend just our particular application and allow you to transfer that knowledge to something else. So hopefully what you learn here is going to be useful, not just in connecting to Zatar. All right. So another couple of pictures, a high level of Zatar to give you an idea of what's going on inside. There's two major components inside Zatar. One is what we call the Zatar core, and that's the part that actually takes the device data, understands the avatar, consumes the avatar definition, and abstracts everything away to this homogeneous REST API. There's the endpoint. It's standard HTTP REST, the sort of CRUDX model, get, put, post, delete, using JSON payloads, encryption using TLS, authorization using auth2, and by connecting up to that, you get all these resources abstracted for you. Avatars, avatar definitions, users, roles, events, and automations. That's at the application side. Not going to talk a ton about that today because we're mostly focused on the device side. And the device endpoint is where your devices connect. Now, the Zatar core component is actually connected internally to this licensed code, licensed component called ARM mBed device server. And ARM has provided this, and we've licensed it, and that manages all the connectivity into the cloud, and we internally talk to it. Right? So I hear some noise. If somebody could mute, that would be great, because it's kind of like distracting. So the thing to understand is that ARM mBed device server in the cloud side talks to a complementary piece of code. If somebody could mute, that'd be awesome. They talk to a complementary piece of code on the device called ARM mBed client or ARM mBed OS, depending upon which one you want to use. mBed client is what we use in the sample and what we're going to show today, and that is open source. So it's in C++. You can go to GitHub and get it and download it and use it, and you don't have to license it. The stuff in the cloud is licensed, but the stuff on the device is open source. So you can actually use it to connect to another cloud, not even ours or something that uses ARM mBed.
All right, folks, sorry we're having some technical difficulties. We just lost our audio to Tom. Let me see if I can try to correct this. Hey, Tom, can you hear us?
I can.
All right, we hear you again. No, we just got you back.
Okay, all right. So hopefully it wasn't going on for too long.
No, it's just probably 30 seconds or so.
All right, so the details of the device endpoint are on the screen right now. And using CoAP and UDP over UDP or TCP is what we exposed today. But the one I wanted to make clear was ARM, with their code, they've got the code at both ends of the channel, so they control it. And you don't really need to know the details about it. But it's important to understand that they're not just going to support CoAP. They're going to support all the major flavors of protocols that are out there. MQTT, if you prefer that, HTTP, if you prefer that. We're just exposing the CoAP protocol today, right? So ARM is going to support everything, but this is what is supported today, and this is what the demo is based on. The other thing I want to point out is we utilize this lightweight M2M object model. That's what the LWM2M at the bottom is. And that's another standard from Open Mobile Alliance, which basically standardized on the semantics. So I send you data, the payload is standardized by CoAP, but the content of the payload, what is it? What's this blob? And that content is standardized by OMA in this device model. And they specify certain standardized payloads that every compliant device need to support. And they're listed here, not inclusively, but the main ones are, manufacturer, serial number, model type. These things, every device that supports lightweight M2M should implement exactly the same way. That means if I connect to cloud A or cloud B, even if they don't know who I am, they'll know that much about my device because these things are all standardized. And I'll show you a little bit more about that later. Okay, so I got to go back into here. Yeah. So this is a picture of the device portal, the Zatar device portal, and this is just an app. It sits on top of our REST API like any other app, and what it does, we provide it because it is very simple and useful, and it shows the worlds you have access to, the devices that you have access to, whether they're yours or shared with you, and the inner circle is your home world. So you can see mine is called Tom at Zatar. And the outer circle are those worlds that are shared with you. And we'll have some more about that later. Here's a picture of the developer zone, developer.zatar.com. If you want to play around with this and get involved, go to developer.zatar.com, sign up, you fill out a form, it's free of course, and you have developer status on Zatar, and you can log on to either the device portal or a developer portal with the same credentials and access the tools excuse me, that we provide for developers to either, attach devices with their code running to Zatar or attach applications that they've written to Zatar. So we'll have to talk about some more of that later. Prerequisites for the demo, obviously you need to have a Raspberry Pi. Pretty much any Raspberry Pi, even a Raspberry Pi Zero will run the demo code, but unless you populate the headers, unless you solder on the GPIO headers and attach the add-on board, you're not going to see any fancy lights. But you need to be connected to the internet, so either wireless or wired Ethernet. You need to have an account on Zatar as a developer, like I just talked about. And if you want the fancy lights and button, you need to have this board we picked called a Pibrella board. There's nothing fancy about it, right? It's just 3 LEDs and a button, but we wanted to have some I/O. We wanted to showcase bidirectional, near real-time interaction with a piece of hardware at the edge via a cloud service through a REST API. So we need to have we need to be able to light a light and detect a button press. Actually, lighting the light is the hard part. Detecting the button press is relatively easy, and that's because of the way the data flows. I mean, if I have a device and I want to push data out to the internet, even behind a firewall, that's easy. I just do a put, or I just do a call out to a service, and that's simple because I'm initiating the connection from inside. But pushing information down to a device from the cloud is the hard part. You have to have some sort of a connection which is maintained open. If it closes, you have to reconnect. All that stuff is handled for you by ARM mBed client, and so that's really much more complicated than pushing stuff out. Let me see if I can show you. This is a picture of a Raspberry Pi 2 that we've done the demo with, but we've done it with just about anything. Hopefully, I'm switching screens now. Hopefully you can see my other screen, and I have a live video going on the upper left-hand corner, and hopefully you can see that, but that's basically a Raspberry Pi Model A, and it's got the Pibrella board. It's great. The Raspberry Pi Model A is there, and the Pibrella board is just this little add-on board, and we're just using it because it has lights and a button. Nothing special. It just plugs in GPIOs. You could use something else, but that's what we chose to use. Okay, So moving on, this slide here is probably one of the most concise and the most important slide in the deck, because it summarizes, if you're a developer and you want to connect a piece of hardware to Zatar, everything you have to do. So I'm going to go through each one of these steps. I think there are 5 steps here. I'm going to summarize it here, and then I'm going to go through each one of the steps, showing you what I can show you, hopefully some of it live. I'm going to try to demo it. If it doesn't work, the screenshots in the deck that hopefully will be provided to you will help clarify and show what's going on. And I will be able to hopefully show you what's happening live. Let's see. So step number 1, you have to figure out what avatar definition you're going to use that describes your device to Zatar. Now, you can create one from scratch, or you can just take one of the canned ones we have, clone it into your account, and modify it to your heart's content for your particular device's needs. Now, you don't have to do this step for the sample, because we've already created a Raspberry Pi IoT kit avatar definition, and we've made it global so it's available to everyone. But if you want to do something special or something unique, this is what you have to do. You have to figure out, what avatar definition am I going to use? And I'll go into that a little bit more detail later. You have to register the code that's going to be running on your device with Zatar and get a token. Basically, you go online, you say, here's my device, I'm a registered developer, I need a token, you check it out, and you stick that token inside your code in your device, and then when your device registers, it hands back the token, and we know who wrote the code, and we know it's from someone we know and trust. All right, that's the second step. The third step is, obviously, you got to write the code that you're going to have on your device that does everything you need to do. I mean, there's a whole bunch of stuff that has to happen. A lot of it is done by mBed client, but you still have to do a lot of it yourself. Most of this stuff has been done for you for the demo, so you're going to get the sample code from the GitHub repo, and you'll have it, and almost all of it's done, but then you'll be able to use that as a baseline if you want to branch out and do something differently with your Raspberry Pi, or even with a different Unix box altogether. Okay, the most important thing is to realize that Zatar links together avatar definition, your code, and the actual physical device by 3 parameters. And those parameters are the device code token, the token you get from the device software manager in step 2. The model that it's just, the model, we're using that to describe the device. And that's what is put in your avatar definition. It's also encoded in your device code token, and it's what is reported by your device. And in this case, we are using Raspberry Pi IoT Kit as the model name, but you can create whatever model name you want. And the UUID, or serial number, which uniquely identifies that particular instance of hardware. Those 3 things get validated when your code connects to Zatar, and if they're not all right, Zatar essentially ignores the device. After you do that, after you've done 1, 2, 3, and 4, your device is connected to Zatar, it's validated, it's running. It's still not good enough, because Zatar does not know who owns this device. And so once the device is connected, it gets into kind of a pool of unclaimed devices until somebody logs on to Zatar.com and then says, I want to add a device into my account, and you type in the serial number of the device, and you go through a couple dialogues to claim the device, and I will show that too. Those are the 5 things that have to be done to connect the device on Zatar. So what I'm going to do now is I'm going to go through each step, hopefully live, but at least you'll see pictures, and show you what that looks like. Okay, so the first step, step 1, choose an avatar definition. Now, once again, you don't have to do this for the demo. It's already done, but I will still want to show it to you and show you what it looks like really quickly. Okay, so here I am back on my browser, and I'm at Zatar, right? I can go over, click this tab, and get to the developer zone. This is what it looks like when you log in to the developer zone. See, I'm logged in there. If you move your cursor over to the left-hand side, a toolbar is revealed with various tools used for the developer activity. The first one you need to select your avatar definition is called Avatar Builder. So you click on Avatar Builder, and you have 2 choices. You can create an avatar, or you can manage the avatars that exist that your account has access to. If I click on Manage Avatar Definitions, I can show you the avatar definition that we are going to use for this demo that has already been done for you. I go to the search box and start typing the name RASP, then it shows all the Raspberry Pi avatar definitions that my account has access to. Now, I have a bunch in my account because I've messed with a bunch, but when you log on for the first time, you will have access to at least one, and that will be this one on the bottom here because it is owned by Zatar Public and it's available to everyone. And that's the one that we've provided for this demo. So if I click on that, it will show you what the avatar definition looks like. Now, if you go to create one, you can actually grab this one, clone it in your account, and then modify it. But we're just showing you what it looks like here in the system. You see the device model, Raspberry Pi IoT Kit. That's where that's entered in. You can change it when you clone it and make it your own, but it's set to Raspberry Pi IoT Kit right now. An avatar definition has 5 distinct parameters in it. There's device descriptive info, there's sensors, there's settings, there's commands, and there's metadata. The first 4 tabs are information which is reported by the device to Zatar. The 5th one is just metadata that we provide a mechanism for the apps API to store data associated with the avatar, descriptive data, whatever you want. You can put whatever you want there. So the first tab is device info. This is stuff mainly which is required. You cannot delete it. You can delete the one on the bottom here, I think. But it's mainly required by lightweight M2M. So the specification requires that information be sent a certain way or it won't be recognized. For instance, manufacturer. If I click on this expander here, I will see the parameters of this, the aspects of this parameter, and I see that it's a string and it has lightweight M2M resource ID 300. It's very important that the proper lightweight M2M resource IDs be used for these resources. So this is object 3, object instance 0, and resource ID 0. So that's defined by the standard to be there and to mean manufacturer. And these things are already put in the avatar definition for you, so you don't have to mess with them. But your code does need to put them in the right spots. Now the sample code already does this, and I'll show you where that's done. But I just kind of wanted to show you where it is in the avatar definition. And so if you do something unique, something special for your device, like over here we did for the Raspberry Pi, red, yellow, green LEDs that on or off, you have to add it in. And you have to tell Zatar, there's the name, there's a description. We made up this lightweight M2M resource ID ourselves. It's a string. And now Zatar knows when the device sends that across, that's the information it needs, and it knows how to abstract that information into the REST API, so a developer using the apps API can actually utilize it without having to know these details. This is where the details stop that deal with the specifics of the device. There are no settings in this sample. There are commands, though. You can toggle the LEDs and clear the button counter. And the metadata, which is not reported by the device, there's always 2, there's a default of 2 that we provide, strings, location and name, but you can add whatever you want. That's how the avatar definition looks in table form that we provide for you. In reality, it's a JSON structure, right? And if you want to look at it, that's what the JSON looks like. The platform consumes this structure, and then it knows how to interact with the device when it connects. It's as simple as that. Okay, that's step 1. Whew, it's a lot of stuff. The good news is you don't really need to do anything to get up and running with the Raspberry Pi demo with respect to this step, but I wanted to show you where it was and what you were going to need to do if you wanted to go further. Step 2, you need a token. You need that device code token that has the right model associated with it so that it will work. And this is something you absolutely have to do or the demo won't work, because I can't give you a token. You have to go and check out the token yourself. So you have to sign up as a developer and do exactly what I'm going to show you now to get your own device code token. So here we are back at the dev zone. Go back to the tools, and now I go to device software manager, and you can either manage the tokens you have or register a new token. So let's select register a new token. This is what you're going to have to do. You have to go into this, select register a token, say, my new token, whatever you want. The model is critical. It has to be the same as the avatar definition. So I'll just start typing RASP. There it is, Raspberry Pi IoT Kit. I select it. If you put in a different model, the demo won't work. Okay, so you have to put that model in and any description you want. doesn't matter. And then you say register token. As soon as you do that, boom, you have a token. And if I say select, then I can go copy and paste that token into my code prior to building and running it. And I'll show you exactly where that needs to be. But this is something you have to do to get the demo to work. Okay, that's step 2. Step 3 is the hardest part, because you actually have to get the code to run on your device if you're going to hook up a device to Zatar. Again, a ton of this has already been done. Almost all of it's been done to get the demo to work. So it will serve hopefully as a good template for you to look and see how things work, and then modify things either on your Raspberry Pi or on some other Linux box to do whatever functions you need to get done. But it's a good start. So pictorially on the right-hand side, we've got Zatar at the top with the 2 main components, ARM mBed device server talking to ARM mBed client. So ARM code on both sides. That interface is completely managed by ARM code, but your code needs to talk to the ARM mBed client. And if I was to have any type of a criticism right now for ARM mBed client, it works okay. It's just the fact that the interface for your code to talk to it is a little cryptic. And so I suggest you look at the sample code, because it will show you, especially if you look at button object, which is the one module in the code that we did last, and it's the cleanest one. It'll show you how to instantiate an integer resource, a string resource, and a command resource. So whether or not you're going to send an integer or a string or have a command come down, you'll be able to see how to make those calls in the mBed client. All right, so like I said before, we're using mBed client. It's open sourced, so you can go get it. I think you need a free account on ARM to actually activate it or whatever, but if you look at the README instructions in the GitHub repo, it will go into excruciating detail on exactly what you need to do to set up your build environment, which is critical to getting this thing to work. It provides all this functionality. mBed client does this for you. So you have to talk to it, but it talks to ARM mBed device server for you. So it's not just for Zatar, but any cloud service that uses the same cloud-based interface code, this will work on. Even some not done by ARM, if it supports this standard interface, lightweight M2M over CoAP. All right, so moving on, for the demo, for this sample demo, all you need to do is go to this GitHub repo, and this is hopefully you'll get this deck with the links embedded in it. And if I click on this link right here, it should just open up the GitHub repo. Yeah, there it is. And so this is what you can get. You just go and clone it. It's public. And if you read the README file, which I strongly suggest you do, it should go into all the detail you need to knowing the prerequisites and setting up the build environment, downloading all the packages you need, including the package manager from ARM to get everything up and running, and tells you how to get the build for the first time. The first time is kind of unique because it has to pull down a bunch of things that you don't have. After that, it goes a lot faster, and then shows you how to build and run your code. Okay, that's very important. Now, if you're going to hook up maybe a different Linux computer or something else, there are articles on ARM, which I have links to embedded in the presentation. The mBed client is on GitHub repo that you can go get to. I'm not going to go into detail because of time constraints, but there's information there that will help you if you're not going to use a Raspberry Pi. Okay, so it's important to understand what we did to get this thing working on Zatar. If you go to ARM's sample code, I'm going to click on that now. Okay, if you go to their article here, they'll talk about how to hook up a Raspberry Pi, all right? But if you follow their code, their example, their code will hook up to ARM's cloud service, right? It will not hook up to Zatar. And if you want to hook this thing up to a different cloud service, be it Zatar or otherwise, there's a few things you have to do. And for Zatar, these are the things you need to do. I've listed them out here. You need to understand how to set up the security. We're not using any security for the demo, but you need how to set that up. You need to obviously point it to the right server. You need to understand the transport and whatever port is being used by that server for that transport. There's a few other parameters you need to set up, the interface lifetime, and keep alive. For Zatar, you have to configure a custom object ID 23854, that's where you put your DCT. That's a Zatar requirement. Other cloud services will probably do authentication some other way. But a lot of that stuff will translate from one cloud service to another, but this one is unique to Zatar. And also you have to configure the right model number. These are the things that have to be done in order to transfer what ARM gives you to what we give you. The good news is we've done that for you in the sample in the GitHub repo that you can download. The only thing you need to do is put in your DCT that you get from the dev zone, because we can't do that for you. And I'll talk about that in a second. Here's the sample code on GitHub. This is a screenshot, so that if you look at this slide deck offline, you can kind of get the context. If you go to the GitHub repo live, which I am doing right now, and you click on the source folder, that's exactly the same thing you'll see. So those are all the sample modules, the code modules. None of this is ARM code. There is one open source class we're using for GPIO just to make it a little bit easier to use the GPIOs, but all the rest is from Zebra. And the ARM code is pulled down when you build the first time. So if you set up the build environment according to the README and follow the instructions, when you build the first time, the package manager will say, oh, you're using mBed client, and it'll run you through the process of authorizing your free account on ARM, and then it will pull down mBed client, all the modules you need for that, and after that you won't have to do it again. But so all the ARM code is pulled directly from ARM or from their resources and not from ours. Okay, there. Oh yeah. So the last thing I want to say is this module right here, Zatar device auth.cpp. So if we go and look at that, that module right there is the one piece of code you're going to have to add your DCT in to get it to work. Now, let me just say, you can clone this repo, follow the instructions to set up the build environment, build the code and run it, and it will build and it will run. But if you don't make any changes, it will not work. It will look like it works. It'll register on Zatar, but Zatar will try to validate the DCT. It won't get the right DCT, and it will then subsequently ignore your device. So you'll be going like, what's going on? It doesn't work. It's because you need to put that DCT in that line, in that one module, and I'll show you that in a second. Okay. Another thing I want to show you is the config file, config.h. This is a place where a lot of the parameters are stored that are important to make sure they're set up right. Now again, all of this is done for you in the sample, but in case you want to make changes, this is where they are. This is the easiest place to make changes. There's the server obviously in the port. So this is for unsecured UDP right now. If you're going to make a change to security, these are some of the spots where you'd make changes, including the security.h file. The manufacturer is right there. Something you might want to try is just making that change, because you can make that change and it wouldn't break anything. It would still work. It just wouldn't report Raspberry Pi. Here is the model number, the most important thing. That's the thing that the device reports. If you change that, the demo won't work, because it won't work with the avatar definition and the DCT that has that embedded in it. You have to change all three or it doesn't work. All right, that's all I want to say about that. So the one thing you have to change is Zatar device auth.cpp. And if we go back to the code here, this is the actual source for that particular file. You'll see right here where it says device token equals this right here, and it says insert your DCT here. So basically you just take this whole chunk right here and you cut that out, and you go to the device software manager and you copy whatever that token is from your account, right? And then you paste it in there and you save it, and then it will build and run and connect to Zatar. So that's where you do it. Just so you can remember if you go back to these slides later. Okay, so after that, then you build and run your code. Now the only thing tricky about that obviously is you have to have the build environment set up properly according to the README file, which it takes like the first time you do it, depending upon the model of Raspberry Pi, takes like 45 minutes to do, so I can't demo that today. But if you set it up properly, then you go to this directory, mBed venv, mBed client, RPi Zatar, and you type YT or YADA build, and it will build. After you've done that, it will put the executable in this directory, which is the source directory, and that's how and then you run it by you have to be in super user mode, and you just run the executable. Once you do that, the Raspberry Pi will actually display on its console some status. It will show you that it's running. Here's the IP address. Here's my unique serial number, and whether or not I succeeded. And if it says it succeeded, then you take that serial number and you claim your Pi on Zatar. And I'm going to show you that now. Hopefully it will work live. So there's the Raspberry Pi, and you can see it's live. It's actually, video is there. And I'm SSH'd in with a terminal window here on my Mac. So I'm in that directory, mBed VNV, mBed client, rpi Zatar, build, arm links, native, source. And so to get the code to run, I just go sudo mBed /mbed client rpi Zatar, and watch the little lights amazingly come on, I hope. And there it is. So the Raspberry Pi is running now, and you see these lights here, these lights, right, little flashy white lights there. That's just a little activity indicator that we put in that shows that the code is running. So if the program freezes or bombs out, those lights will stop flashing. You kind of know, oh, it's not working anymore. Something happened. It died, right? There's the three LEDs. The three LEDs are here, and the button, those are the ones which actually are interacting with Zatar. So if you look at the console, down at the bottom, you can see welcome to the demo. It says, here's my IP address that I discovered. There is the serial number of the board. There's the endpoint that it's going to. There's the server. It shows all the objects being created, the LEDs, 3 LED objects and a button object. And here's the important part. It says, registering the device on Zatar, registered. And when it says success, that means it worked and it's actually on Zatar, properly registered. And then it says go to Zatar and claim your Pi. There's your serial number, right? So you're on Zatar now, the device is connected, but you're not really, it's not associated with your account yet. So the next thing you need to do is claim the Pi. And you do that by going into your account and saying add device, and I'm going to show you that now. If I go over here and I go back to the device portal, I need to go to my home world, again, which is the inner circle. I click on that one. Okay. I click on my home world, and I say devices, add device. If I go over here, I can copy and paste the serial number. And I say next. Then I have to fill out this dialog box. And the slide deck will tell you what to fill it out as, but the model needs to be Raspberry Pi IoT Kit by now. I've harped on that enough. So if you just click in there and you type RAS, there's Raspberry Pi IoT Kit. If I select it, then if you do that first, the other ones become easy because there's only one choice for each one, and it's hard to get that wrong. So once you've got the model right, you can't get the rest wrong. But there may be a situation. The whole purpose of this dialog is to choose the avatar definition that you want, because there could be more than one that is compatible, like in the example of my account, where there's a bunch of them that are compatible. So you need to pick which one that you want the Zatar to use for this particular device. And you should pick the one that says author Zatar, because that's the public one. So you click next. Then you can add the metadata that I talked about before. I can say my demo device, my demo location, whatever. I can add anything I want, and I say finish, and then it adds it in, and it's visible on the device portal. And you can see my demo device. It shows the status of all of the interactions that you see. It's in the device list. There's the serial number. It gives you information like your IP address, which is really useful because, when you're online, you're like, what's the IP address of that device locally? Right? You can toggle the LEDs. So if you watch the little video screen there and I hit toggle red, it goes out. I hit toggle green. That's the hard part. I'm pushing into that device, and I'm making a round trip to the cloud, and it's actually pretty fast. Near real-time performance. If I hit this button, if I hold the button down, you can see locally the screen actually is telling me what's going on locally in the console window as well. But if I go back to the device portal, you see it shows me that the button state is down as long as I hold the button down, and the button counter is 1. If I let the button up, it goes back to up. So it shows you what's going on. I have bidirectional, near real-time interaction with a Raspberry Pi running Linux using Zatar. And that's basically the demo. Then the couple other things I want to touch on real quick, because I see I'm running out of time, is not only is it accessible via the device portal, but it's obviously accessible via the API, because the device portal uses the API. And so the way to do that is to go back to the dev zone, select API docs, and you have access to the API right here. Very quickly, first thing you need to know is what world you want to use. So you have to authenticate like with anything else, because it's an app. So I have to authorize access into my account by clicking through that. But now that I'm authorized, I can go get the worlds list for my account that I authorize. I need the one that is CRUD-XO, which I own. So I'm scrolling down, looking for the one that says O. Right there, it's Tom at Zatar, that's my world. I select the world ID. Now I can go look at the avatars in that world. By doing a get on all the avatars, I paste in the world ID. I'm already authenticated because I did that already. And I say, try it out, hit the button. And now these are all the avatars. Now I'm looking for the avatar that I named my demo device, right? So I got to look for something that says my demo device. That's not it. Right here, see name my demo device. So this is what you get when you do a get on this endpoint on the application API with Zatar. You get all this information, and you can see the green status is on, yellow status is on, red status is off, just like what you see in the video. The area between the attributes brackets, between here and there, that's what's reported by the avatar, the 5 parameters in the avatar definition I talked about. All the other information is metadata, which is reported by the system. It's important stuff, right? Home world, command jobs, world shared with. But the avatar itself reports the stuff in between the attributes bracket. And you can do a put, on toggle yellow LED if you want to, and you can programmatically control this device from the REST API. What's cool is about you don't really need to know about how the device works or any code on the device. You can just use REST. Okay, that's that. I don't really have a lot of time to talk about this, but you can read through it. If you want to add your own object, then you're going to have to do all these functions here, which I suggest you look at buttonObject.cpp in the sample code, and it will walk you through not only data being pushed up to the cloud from the button, but also when you want to clear the button counter, you need to send a command. And so you'll have to have a callback into your code. It shows you how to do all that. So if you look at buttonObject.cpp and buttonObject.h, along with the stuff that was mentioned here about the main program, it will show you how to do that. I'm sorry I don't have more time to talk about it. Next steps, sign up for the account, get your Raspberry Pi, and have fun. And here's some resources, a blog, a video. We have 2 GitHub repos. One of them is just the executables with canned DCT, so if you just want to run the code and you don't want to build it, and one that has the code that you can build and run and make modifications to. There's the Zatar resources, Pibrella, Open Mobile Alliance if you want to learn more about lightweight M2M, and if you want to know about mBed, there's the mBed URI. Only a couple things at the end. I would just say if you want to know more about the details of the lightweight M2M model, I've added that in the end, and I've also shown an example, the detail of what we support in Zatar regarding lightweight M2M. And with that, I'm done, and I'm happy to entertain questions.
Excellent. Thank you very much, Tom. This was great. Give us a really nice overview and even some nice homework and ways we can go and do it ourselves and then look for other devices we want to connect. So that was great. I did want to let everyone know we will be taking the video of this and Tom's slides and posting them on the original post on developer.zebra.com that we have for this dev talk. So you'll be able to see his slides with all the links that he's been showing. And now for the questions. First one we had was, is it necessary to use the Zatar gateway?
Yeah, the gateway, I'm assuming you're referring to there's an NUC computer that we were providing to people to talk to devices, and the answer is no. We actually aren't even, to my knowledge, I don't believe we're supporting that gateway anymore. So if you put this code on the Raspberry Pi or any Linux box that we talked about, it directly connects. There's no other hardware involved.
Great. Thanks, Tom. One other question we have, does the demo app require this specific LED and button expansion board, or can we use other configurations or use standard RPI, GPIO?
Yeah, so in order for the actual lights to work the way I showed, you have to use the Pibrella board. If you don't have a Pibrella board, you can still download and run the code on any Raspberry Pi, including a Raspberry Pi Zero, but you won't see the lights. If you stick a scope on the GPIOs, you can look and you see which GPIOs are you using. If you look at the code, you'll see which ones we're using, and you can actually see the levels go up and down. And you can hook. I actually have separate LEDs on a Pro board right now that are flashing that use the same thing. So yeah, you don't really need the board if you know how to hook up to GPIOs.
Okay, great. So we got a follow-up on the gateway, and the person's just curious of how they connect their device if they don't have the gateway. You could speak a little more to that.
Yeah, you don't need a gateway. The way mBed works, before when we had a gateway, we didn't really have the code we needed to talk directly to Zatar. We didn't have that, so we had to create it ourselves in a kind of a custom fashion, which was really hard to replicate. Now, in the last year, ARM came out with this whole mBed concept, which we licensed, and so now the code that mBed client code, which gets pulled down when you do the build for the first time on the Raspberry Pi, that mBed client is sort of like a gateway, and it's right on. It runs right on your Raspberry Pi. It's C++ too, so and it's open sourced. So you don't need to run it on a Raspberry Pi. If you can compile it, you can run it on anything that can run C++ that has a network stack. But it's a lot more complicated to port it, although ARM talks about that. So you don't need a gateway. The code if you have a device which is connected to the internet, like a Raspberry Pi has internet connectivity, either Wi-Fi or wired Ethernet, it'll directly connect right to the cloud.
Okay, thanks, Tom. Let's see, no other questions are coming up right now. Anyone else have any other questions we can ask Tom? All right, I think that's it. Tom, do you have any other last comments?
All I would just say is I encourage you to try it out, right? I mean, there's two ways to do it. If you don't want to build the code, just go get the executables. And there's a video. If you go to the resources, there's a video of me showing how to do that, and there's a blog that talks about it. Just if you want to get a Raspberry Pi hooked up, I mean, literally, it takes a minute. And if you want to play around, I suggest you look at that button object, and that will show you how the code is constructed. And thank you very much. I appreciate the opportunity to talk to you guys.
You bet. Thank you, Tom. And again, for everyone still on, there's going to be, when you close out of this, there's some survey questions just so we can try to understand how well we did here. And if you could fill that out, and then we will have, probably in the next week or so, we'll start sending more information out about the next sessions. So again, these slides we will be posting online at developer.zebra.com in the developer events area. And we thank you very much to everyone for participating. We will talk with you in 3 weeks at our next session. Thank you.
Okay. Thanks a lot, Dan. Thanks, everybody.